This screencast podcast is going to go over stoichiometry, the basics of it at least. And that's a funny word, but the funny word of stoichiometry is simply the study of mathematical relationships in a chemical equation. And that is a relationship between how the ingredients or the reactants relate to each other and also to the products. Now, this takes place whether you're making Windex or a zit cream or a cake or a car. All these things have to do with a ratio or a balance. And so therefore, they must all be based on a balanced equation. I'm going to go through a simple relationship so you can get an idea of how this works. And I'm going to use equivalencies, or things that are equal to each other. And so I have this recipe. I love yummy cake. And so to make yummy cake, I take 2 eggs and 1 box of cake mix, and that's going to make 1 yummy cake. Now if you look, I have all these equivalencies, the relationships between the different ingredients and my products. I have 2 eggs equals 1 yummy cake, because that's true. I can see that 1 box of cake mix equals 1 yummy cake. I can also see that 2 eggs equal 1 box mix. And I can see that 1 egg is equal to 50 cracked eggs. I looked that up online. Now, let's use these relationships to do some problems. First, I have a problem that seems very simple, and so let's start with something simple because it's going to get more complicated. So let's learn how to do the math. We're basically going to use some of the ideas that we use when we use moles, and we're going to take these forward with us. So what do we know? We know we have 6 eggs, and we want to know how many cakes we can make. And if we follow the process we've always done, we underline what we know and circle what we don't. So I know for a fact that I have 6 eggs. And I'm going to write that down because that's what I know. That's what I'm starting with. Now, I'm going to go ahead for this first problem, or 2, and draw parentheses like this. But you also know I can do this with train tracks, right? Okay, so that's what I'm going to end up doing later on. So I'm putting 6 eggs over here because I do not want eggs. I want to cancel that word eggs. So I'm going to put the word eggs down here. And I'm going to look at my relationship and I'm going to say, what is the relationship that I have between eggs and cakes? Do I have one? And you would look at your equivalencies and say that for every 2 eggs, that equals 1 yummy cake. I love yummy cake. So, what am I going to do? I'm going to go ahead and put the word yummy cake up here. And I should put yummy cake up here also. All right? And so what do I know? What have I done? By putting the words here, before I even put numbers, I've taken the word eggs and I've gotten rid of it. And I've changed it to yummy cake. I'm going to use my equivalency, or more my ratio, my relationship, that 2 eggs equals 1 yummy cake. That is true. That is a fact that I looked here in my balanced equation or my recipe. So now my eggs cancel, and I can take 6 times 1 divided by 2, and that equals 3 yummy, yummy cakes. Let's try another one. Okay. Now, what do I know? I know if I have 600 grams of eggs, I want to look and see how many cakes I can make. So I've underlined my 600 grams right here, 600 grams, and I've circled how many cakes, yummy cakes. And I'm going to use 2 of my equivalencies. I know that 1 egg equals 50 grams of cracked eggs, and I have 2 eggs equals 1 yummy cake. So to get rid of this eggs so it doesn't confuse you, I'm just going to look at the word grams. And I'm going to go ahead and draw my train tracks. I know it's going to be a couple long, so I'm going to go ahead and just leave it out there. And I do not want grams, so I'm going to put the word grams down here. And I know that if I have 50 grams, that's going to give me 1 egg. So I have just changed grams to eggs by using this equivalency right here. And I don't want eggs. I want yummy cakes. And you might say, who in the world talks about grams of eggs? I mean, when you look at a recipe, you use 2. Well, if you cook for the Army, or if you cook for a Mother's Day brunch, or for Wegmans, or if you're a truck driver and you're driving around eggs, you don't care about how many there are, you care about how much they weigh. If I'm a triathlete, if I'm a diabetic, if I'm watching my weight, I weigh all my food. So there are people that do this. So, now I'm at eggs. I got a problem because I want to change it to cakes. So I need another train track. I put the word egg down here because my eggs are going to cancel. I'm going to change it to the word yummy cake. And what do I know about eggs and yummy cake? I know that 2 eggs equals 1 yummy cake. So what have I done? I've taken 600 grams and I've canceled the word grams and changed it to eggs. Then I cancel the word eggs and I change it to yummy cake using my equivalencies. And to do my math, I take 600 times 1 divided by 50 times 1, right? Times divided times divided. So it's 600 times 1 divided by 50 times 1 divided by 2, or however you do it, and you're going to come up with 6 yummy cakes. Okay? Now, we're not going to talk about yummy cakes all the time. We're going to talk about relationships or equivalencies in a balanced equation. And this equation is balanced. I've got 2 magnesiums over here, and 2 magnesiums here, 2 oxygens, and 2 oxygens. So therefore it is balanced. I need to make sure of that before I start. Let's look at our equivalencies here. Just like our yummy cake, we have for every 2 moles, because that's what that 2 means in front of the coefficient. That means 2 moles are molecules. Okay? So 2 moles of Mg, what do you have? That's equal to 1 mole of oxygen. Because for every 2 of these, you need 1 of those. Isn't that a relationship right there between those 2 items? It is. Just like your box and your eggs, okay? And that 1's not written, but I can write it there. Now, what else do I know? I have a relationship between oxygen and magnesium oxide. And that's for every 1 mole of oxygen, right? 1 mole. I'm going to look at these 2 now, right here. I make 2 moles of magnesium oxide. That's another equivalency. So now what's a third equivalency? I'm going to look at the relationship between these 2 guys right here. So for every 2 moles of Mg, I can make 2 moles of magnesium oxide. And those are my equivalencies, my ratios. I'm going to call them molar ratios because they're ratios between the moles in a balanced equation. So, what's true? The coefficients in a balanced equation give the molar ratio for the ingredients that are involved in the equation. And remember, the equation has to be balanced, right? Otherwise, you just make a mess. When you make turkey and stuffing and sweet potatoes and all the yummy things you make, you need to make sure that you have a balanced recipe, a balanced equation. So let's use this equation to do some problems. My first problem is I have 2 moles of magnesium. How many moles of oxygen do I need? So I'm going to go ahead, I'm going to underline what I know. I'm going to circle, okay, there you go, sorry, I wrote it over there, what I don't know. So what do? I write down what I know. I have 2 moles of magnesium, all right, and I do not want that. So I'm going to write moles of magnesium down here. Now, before when you were doing just a mole map problem, I didn't mind if you didn't label every step. Here you have to, because you're dealing with so many different things. You have to label what you have and what the word that goes with it is. So what have I done? I've gotten rid of the moles of magnesium. All right, and what do I know? I'm going to look at my balanced equation for my relationship between them. Okay, so we call these mole-mole problems, by the way, because we're going from moles of one thing to moles of another using our balanced equation. So what do I know? I know that I have 2 moles of magnesium in my balanced equation, right? And I have 1 mole of oxygen. I have taken what I have right here, my moles of magnesium. I've gotten rid of it, and I've changed it to what I need or what I want by using the coefficients in my balanced equation. So now I take 2 times 1 divided by 2, and I get 1 mole of oxygen. Which you can say, well, heck, Miss Faley, you could have looked at the balanced equation and you could have said that, and that's true. But again, we're showing how to simply do these problems when it's basic and understandable, okay, because it's going to get more complicated pretty quickly. All right, so here we go. We're going to call this a mole-mole problem. How come? Because it's going from moles of one thing to moles of another. Right now, what kind of moles are there? You know that you have 38 moles of magnesium oxide, so right away you're going to write down 38 moles of MgO. All right, they're produced. How many moles of magnesium were used? Well, that's what you want to know. So you can go ahead and label your answer. So now you're going to look at your balanced equation and you're going to look at the relationship between these two. Where is that? That's these two guys right here, right? And so some of you will say, well, why do you need this? Well, you only need it to balance the equation, but we don't need it for this problem. So what do? I take my words up top, my moles of magnesium oxide. I put my words down below. I do not want it. And I'm going to go ahead and change it to moles of Mg because that's what I want. I've taken what I have and gotten rid of the words and changed it to what I want to obtain. Okay, what I have to what I need. That's what I've done. Now where do I get the information for this section right here? Where do I get that? Well, I get it from my balanced equation. And up here I have 2 moles of magnesium, excuse me, 2 moles of magnesium oxide, my bad. And here I have 2 moles of magnesium. That's where I get those numbers from. And I simply copy them down next to the words that correspond to whatever I'm looking at in my balanced equation. And if I take 38 times 2 divided by 2, I end up with 38. Which makes sense because what you start with here, you're going to make the same amount on this side. And again, you're saying, well, why bother with this? Well, stick around and you'll see. Okay? Now, if you turn the page in your packet, we're going to look at what we have here. You know your mole map. If you don't, you need to reacquaint yourself with it. And I have 1 mole here. And here's volume in liters. Just watch, please, okay? You've got this written down on your paper. I've got grams from a periodic table, 22.4, okay? This is volume in liters at STP. And here's 6.02 times 10 to the 23rd. And down here are words like molecules, ions, atoms, and formula units. And that's true for 1 item. So for every single compound or element, you have a mole map. So we're going to go ahead and say this is what we have when we have an equation. And you're going to have another mole map for what you need. And any mole map and any compound has always been the same, or any element, hasn't it? So we're just going to draw a reverse of it right here. So all I'm doing is copying this down. Again, please just watch. This is molecules, formula units, ions, atoms. And I've got 1 mole in here. So this is going to be what I need. So you have a mole map for what you have, and you have a mole map for what you need. But how can you relate them to each other? Right now, there's a huge chasm between them. There's a huge divide. It's almost like there's a river running between these two worlds. So you need a way to relate them. So to do that, you need to build a bridge so that the moles on this side can visit the moles on this side. So to build a bridge takes some time, and you've had time. You've learned how to balance equations, and you've learned how to do mole maps. So we're going to call this the balanced equation bridge. And I have a pretty picture on the next page, and you also have it on your sheet. The balanced equation bridge is what connects moles of what we have to moles of what we need. Do you see that? If this wasn't here, what would happen? Oh goodness, there'd be a river, and there's no way they could visit each other. But now there's a bridge. And in that bridge, there are coefficients. And those coefficients have a fancy name. We've called them molar ratios. So we are going to go ahead and call this the molar ratio river and the coefficient rapids. And you can see very clearly that there's a balanced equation that goes between them. So let's do some problems that help us use this. And for the problems we're going to do right now, we're only going to use parts of it. We're not going to use the part that goes between volume or molecules. We're simply going to look at this leg of the bridge, okay? So to start off with, I'm going to have an equation, which is sodium plus chlorine makes 2 NaCl. Excuse me, I shouldn't put the 2 there. Just makes NaCl. And if you see S here, that means solid, and G means gas, and S means solid. This equation is not balanced. I have 1 sodium on this side and 1 sodium on this side. That's cool. I have 2 chlorines on this side and only 1 over here. So I need to balance this by putting a 2 out front so my chlorines are fixed. But that also affects my sodiums, so I need to put a 2 out here. And now I have a balanced equation or a recipe. Okay? Now, let's do some problems. I'm going to go ahead and I'm going to say that I have 3 moles of solid sodium reacts with chlorine gas to produce sodium chloride. How many moles of chlorine gas are required? Well, if my problem says I have 3 moles of sodium and I want to know how many moles of chlorine gas. So this is my problem. 3 moles of sodium equals how many moles of chlorine. We're going to call this a mole-mole relationship because it's a mole-mole problem because I'm going between moles and moles. And so if you look, I don't need this part. I don't need grams in the periodic table. I simply am going back and forth between moles of what I have and moles of what I want or what I need. What do I have? I have sodium. So this is where sodium lives. This is sodium's land. And this is chlorine's land. And the way you're going to get back and forth between sodium and chlorine, between sodium's mole hole and chlorine's mole hole, is to use your balanced equation bridge. So let's do that. What have we done? We underline what we know, 3 moles of sodium. We circle what we don't know, moles of chlorine, which is what I've done down here. And I go ahead and I say, I do not want moles of sodium. I do want moles of chlorine. And in my balanced equation, what is true? I look here and I have 2 moles of sodium, and I have 1 mole of chlorine. And I fill those numbers in on my balanced equation. So when I take 3 times 1 divided by 2, I get 3 halves, or 1.5 moles of chlorine. That's how I do this problem. I'm going to use this relationship the whole time. So, what am I going to do now? What do I have? I wonder if I wrote these down over here. No, I didn't. Whoops. Sorry. So let's go back over here. So in my next problem, I have 30 grams of sodium that are to use in an experiment, and I don't know how many moles of chlorine I'm going to use. My balanced equation was 2Na plus Cl2 makes 2NaCl. And if those solids and gases, the little S's and G's bother you, ignore them. So, what's true? This is sodium's land over here. Sodium lives over here. And chlorine lives over here. Because those are my 2 elements. This is what I have, and this is what I need, right? This is what I have, and this is what I need. Now, what's true? I'm going to go ahead and always write down what I have. 30 grams of sodium. Okay? And over here, I'm going to write down what I need. I've got moles of chlorine. So now I'm going to go ahead and erase this because this is in my way. Now, where am I on this progress map that I'm using? Am I in moles of sodium right here? Whoops. Is that what it says right here? Does it say moles? Or no, it says grams. Ah. So if it says grams of sodium, I'm right here. That means to go from grams of sodium, I need to go from grams to moles of sodium. I'm still on the mole map, aren't I? And then I need to cross my balanced equation bridge to go from moles of what I have to moles of what I need. And that's where I stop, because that's what it tells me. It tells me I have moles and I want to stop there. So I don't need this section for this problem. Okay? So watch. I'm going to start at grams of sodium. Here's step 1. So I'm going to go ahead and take grams of sodium. I do not want grams of sodium. I'm going to change it to moles of sodium, because that's exactly what happens right here. I go from grams to moles of what I have. I'm on a mole map. And I have 1 mole of sodium. I have 22.99 grams. Okay? Now, I'm right here. Do I want to be there? Oh no. I want to go over to chlorine's land. So what do I have to do to do that? Oh, you say, I need to use the balanced equation. Okay, so this is part 1, which I just did down here. Now I'm going to do step 2. And step 2 is to get rid of moles of sodium, right? I'm in the mole hole for sodium. I don't want to be there. I want to cross the bridge and go to chlorine. So I'm going to go to moles of chlorine. I'm going to look at my balanced equation, and what's true in my balanced equation? For every 2 of these, I need 1 of those. So I go ahead and put 2 moles of sodium and 1 mole of chlorine, and now I do my math. I take 30 times 1 divided by 22.99 times 1 divided by 2, and I get 0.65 moles. Seems complicated, but we can do this. Okay? Let's go ahead and practice again. I'm going to go ahead and I'm going to say, what happens if I have 40 grams of chlorine? How many moles of NaCl do I make? Okay? So what do you have? You have 40 grams of chlorine. You're right here. Where do you need to end up? You need to end up in moles of sodium chloride. So you don't need this section right here. Okay? So what's your first step? To change grams to moles. So I'm going to do that right here. So I take 40 grams of chlorine, right? I write down what I have. I do not want grams, I'm changing it to moles. And I have 1 mole because I'm on a mole map. Okay, and this is moles of chlorine because that's what I have. And chlorine's Cl2. So you take 35.45 plus 35.45 off the periodic table, right? And that's 70.9 grams. Now, where are you physically? You're physically in the mole hole. You do not want to be in the mole hole of chlorine. You want to go to the mole hole of sodium chloride. How do you get there? Oh, you say, cross the balanced equation bridge. All right. To do that, I actually need a balanced equation. So my balanced equation was what? 2Na plus 1Cl2 makes 2NaCl. Which two am I going to look at? I'm only going to look at the relationship between these two right here. So to do that, what do I need to do? Do I want to be in the mole hole of chlorine? Nope. So I write moles of chlorine down here because that's the words that are up here, right? Moles of chlorine are up top. I do not want them, so I write them down here. When I am done writing them, then I say, where do I want to go? Oh, I want to go across the bridge to moles of sodium chloride because that's where I want to end up. I want to end up in sodium chloride's mole hole. And what do I know from my balanced equation? That for every one of these chlorines, I make 2 sodium chlorides. So now how do I do my math? 40 times 1 divided by 70.9 times 2 divided by 1, or forget about the ones. And when you're done, you should come up with 1.128 or 1.13. And what am I going to label that? Moles of NaCl. How come? Because my grams cancel, my moles cancel, and I'm left with moles of where I want to end up. Let's try one more. In this problem, I have 65 grams of sodium chloride. And I want to know how many grams of chlorine gas were used. Please go away. I'm sorry. There's a sign on the door. Okay? So if I have 65 grams of sodium chloride, I really can't talk. I'm really sorry. I have 65 grams of sodium chloride. What do I have to do? I've got to take grams of sodium chloride to moles. I'm trying to get from grams of what I have right here all the way over here. What's the path you have to follow? I'm going to take grams of sodium chloride. I do not want it. I'm going to change it to moles of sodium chloride. Why? Because I'm on this mole map for sodium chloride. To do that, there's 1 mole in that mole hole because I'm on a mole map. And I need to add up sodium and chlorine, 22.99 and 35.45. Why am I adding those up? Because I'm using my periodic table. And that mass is 58.44. So I'm going to go ahead and put that 58.44 right here. Okay? Now, where am I physically right now? I am physically right here in the mole hole for sodium chloride. But I don't want to be there. I want to go all the way over to grams of chlorine right here. So now that I'm here, what do I have to do to get from the mole hole of sodium chloride to the mole hole of chlorine? Oh, you say, let's use the balanced equation. So let's cross that bridge. What was my balanced equation again? For every 2 Na, I need 1 chlorine to make 2 NaCl. And which 2 am I looking at? I'm not looking at the sodium. I need that to do my equation, but I'm looking at the relationship between these 2. So I'm going to go ahead and use a different color for this step so you can see. Or an eraser, hey. So I do not want moles of sodium chloride. I'm physically going to leave this mole hole and move over here to the mole hole of chlorine. Now look at that. What do I need to do? For every 2 sodium chlorides, right here, right, 2, I have 1 chlorine. Where am I looking at that? I'm looking at my balanced equation, at my coefficients, at my molar ratio. Now, if this said moles, I'd stop. But that's not what it says. It says grams. So I need to keep going. I need to take moles of chlorine and I need to change it to grams of chlorine. Now how do I do that? Oh, I'm on a mole map. I'm not on a balanced equation bridge anymore. I'm on a mole map. And everyone knows on a mole map that in 1 mole, and to do chlorine, what do? 35.45 and 35.45, 70.9, and I'm going to have this bell ring, is 39.42 grams of chlorine.
Head to your A1 class.